Hello students, welcome to chemistry classes. Today we are going to discuss some topic and problems in basic concepts of chemistry. So first of all, we are going to discuss one term called limiting reagent. So what is limiting reagent? What is the effect of limiting reagent on chemical reactions? We know that the reactant molecules react together to produce the product. Let us consider A plus B giving C as the product. A and B completely react together to produce the product. After the formation of product, we can't expect reactants in the reaction medium. But in many practice, one of the reactant may be larger and another reagent may be in smaller quantity. So large quantity, this is smaller quantity. The reactants react together to produce the product. Which reactant control the entire chemical reaction? That means there will be no formation of product occurs after the consumption of one of the reactants or after the complete consumption of one of the reactant. That reactant is called limiting reagent. Limiting reagent which control the entire reaction. Why it control the reaction? After the complete consumption of the reactant B, no more reaction occurs. No more products are formed. But in the reaction medium contains certain amount of A. This is called limiting reagent. Limiting reagent. So it can be explained with the help of one problem. Listen, 50 kilogram of nitrogen reacts with 10 kilogram of hydrogen gives ammonia. Calculate the amount of ammonia formed during the end of the reaction. Identify the limiting reagent of this process. So you remember 50 kilogram of nitrogen reactions. Normally the reaction is written like this: nitrogen gas reacts with 3 moles of hydrogen gas gives 2 moles of ammonia gas. This is the overall reaction takes place. Nitrogen, 1 mole of nitrogen reacts with 3 mole of hydrogen gives 2 moles of product. In this problem we are taking 50 kilogram of nitrogen reacts with 10 kilogram of hydrogen to form how much quantity of ammonia? 50 kilogram. So first you find out number of moles of nitrogen, number of moles of hydrogen. Number of moles of nitrogen is equal to 50 into 10 to the power 3 kilogram, that is gram, kilogram into gram, divided by 28. 28 is the molar mass of nitrogen, that is 17.86 into 10 to the power 2 moles of nitrogen present in 50 kilogram of nitrogen. Similarly, number of moles of hydrogen is equal to 10 into 10 to the power 3, 10 into 10 to the power 3, here 10 kilogram is there, 10 into 10 to the power 3 divided by 2, 2 is the molar mass of hydrogen, that is equal to 5 into 10 to the power 3 moles. Listen, 1 mole of nitrogen reacts with 3 moles of hydrogen. Number of moles required to react with hydrogen is 50 kilogram of nitrogen is there. Number of moles of hydrogen required to react with nitrogen Here 17.86 moles of nitrogen is present. Here 5 into 10 to the power 3 moles of hydrogen is there. But 3 moles of hydrogen reacts with nitrogen. So 3 into 17.86 into 10 to the power 2. This much amount is required to react with 50 kilogram of nitrogen. But in practice only 5 into 36 in 5.36 into 10 to the power 3 moles of hydrogen is required to react with 50 kilogram of nitrogen. But based on the mole calculation only, how much quantity of hydrogen present is 5 into 10 to the power 3. The requirement is 5.36 into 10 to the power 3 moles. So which one is the limiting reagent? So after the complete consumption of this much amount of hydrogen, no more reaction may occur, no more product can be formed. So hydrogen control the entire reaction of this process. So hydrogen is act as a limiting reagent. 3 moles of hydrogen gives 2 moles of ammonia. Therefore 2 by 3 moles of hydrogen gives 2 moles of ammonia into 5 into 10 to the power 3, that is 3.3633 into 10 to the power 3. Weight of ammonia formed is equal to molar weight of ammonia. Molar weight of ammonia is 17 into 3.33 into 10 to the power 3. Therefore 50.61 kilogram of ammonia is formed during the course of the process. So this is the limiting reagent. Last only one question, that is problem 1.8. The density of 3 mole of solution of sodium chloride is 1.25 gram per liter. Calculate the molality of the solution. Molality. How to calculate the molality? We must know mass of the solute and volume of the solvent. Here no more evidences available for calculating the molality, but only one term given is density. You know density, mass per volume is called density. Density is equal to 1.25 gram per liter. Mole, concentration of the solution equal to 3 mole per liter. Number of moles is equal to weight divided by molecular weight. So weight of the solute is equal to moles into molar weight. Molar mass of sodium chloride is 58 point. Molar mass of sodium chloride is 58.5. Therefore, weight of the solute is equal to 175.3 gram. This 175.5 gram is present in 3 molar solution. So solute plus solvent. Solute plus solvent amount is, that is 3 molar solution. Density is equal to mass by volume, that is mass is equal to, from this we can find out the mass, 1.25 into 1000. 1.25 into 1000. 1.25 mass is equal to 1250 gram. 1250 gram. Therefore, solute amount 175.5 gram. Mass of the solution, that is equal to 1250 gram. Therefore, mass of solvent, water present in the solution, that is equal to 1250 minus 175.5, that is 1074.5 gram. Therefore, molality M is equal to concentration 3m divided by 1.074 kilogram. Gram is converted into kilogram. So 2.79 mole. 2.79 mole is the molality of the solution. So up to this, I conclude this lesson. The notes for this lesson is given in the PDF form. You go through the lesson very well, study the lesson very well. If you have any doubts, you may ask. Thank you.